Good morning. We are dealing with the chapter Measurements and Units. In the last class, we have discussed about mass, time, etc. Today's class, we are going to deal with fundamental quantity and derived quantity. Okay, we can divide quantities into two. They are fundamental quantities and derived quantities. What do you mean by fundamental quantity? I think fundamental quantity is a familiar word up to you. What do you mean by fundamental quantity? By definition, we can say quantities which are not related to one another and cannot be expressed using other quantities are called fundamental quantities. Okay, once more I will say what is fundamental quantity. The quantities which are not related to one another and cannot be expressed using other quantities are called fundamental quantities. Simply we can say it does not depend upon any other physical quantities for its measurements. Okay, I think all of you got it. Okay, look at here. Fundamental quantity. Is length is a type of fundamental quantity? Yes, length is a type of fundamental quantity. Okay. Okay, length is a type of fundamental quantity. We can measure the length directly by using a scale, isn't it? We can measure the length by directly using a scale. And what is in the case of mass? We can also measure directly this mass by using a balance. Okay, so as in the case of derived quantity, for example, area. How can we calculate area? Area is equal to length into breadth. Okay, how can we calculate area? Area is equal to length into breadth. Is this length and breadth are a type of fundamental quantity, isn't it? Is this length and breadth are a type of fundamental quantities? Okay, so we can call this length and breadth are fundamental quantities. So this area is a dependable quantity. Okay, this area is a dependable quantity. Hence we can call this area as a derived quantity. Okay, isn't it? Is it clear? Once more I will say area, we can calculate area by length into breadth. Okay, here the length and breadth are a type of fundamental quantity. Okay, so the area is dependable upon this fundamental quantity. Hence this area is a derived quantity. Okay, is it clear? The units of fundamental quantities are called fundamental units. The system is based on fundamental units, that is International System of Units. In short form we can say SI units. Okay, length, mass, time, temperature, electric current, etc. are fundamental units. Okay, look at here. Here you can see a picture. Okay, in this picture contains important fundamental quantities. You must go through it and learn it. Okay, units which are expressed in terms of fundamental quantities are called derived quantities. Okay, so what's the difference between fundamental units and derived units? The units of fundamental quantities are called fundamental units and the units which are expressed in terms of fundamental quantities are called derived units. Okay, is it clear? Do you know which are the salient features of SI units? Which are the salient features of SI units? The salient features of SI units are, first one, they have unified units. Okay, they have unified units. Okay, the first one is they have unified units. That means they are uniform in nature. Okay, second one is they are internationally accepted. Okay, they are internationally accepted. Then the third one is adequate to express all quantities. Okay, adequate to express all Adequate to express all physical quantities. Okay. Okay, so these three are the salient features of SI units. They have unified units, internationally accepted and adequate to express all physical quantities. Okay, then how can we calculate the unit of area? How can we calculate the unit of area? We can calculate unit of area by unit of area is equal to unit of length into unit of breadth. Okay. Unit of area is equal to unit of length into breadth. Here the unit of length is meter and the unit of breadth is also meter. So we can write meter square. Okay, by calculating this we will get meter square. Okay, so the SI unit of area is meter square. Okay, I think all of you got it. Next we move to another topic, another quantity, that is volume. Okay, volume. I think volume is a familiar word up to you. How can we measure the volume of a cube or cuboid? How can you find volume? Volume is equal to length into breadth into height. Okay, volume is equal to length into breadth into height. Okay. Okay, this length into breadth into height are a type of length, isn't it? This length into breadth into height are fundamental quantities. This length is a fundamental quantity, breadth is also a fundamental quantity and height is also a fundamental quantity. Okay, for measuring the volume, these all are fundamental quantities. Hence, volume is a derived quantity. Okay. Then, how can we calculate the unit of volume? How can we calculate the unit of volume? Here, the unit of length is meter. Okay. And the unit of breadth is also meter. And the unit of height is also meter. Is it clear? Then, multiplying this, we will get cubic meter. Okay. You can call this cubic meter or meter cube. So, the SI unit of volume is cubic meter. Is it clear? Okay. Next we move to another quantity, that is density. Density. I think this density, this word is almost familiar up to you, isn't it? Density can be calculated by mass per unit volume of a substance. Once more I will say, by definition we can say density can be calculated by mass per unit volume of a substance. Okay, so we can write density is equal to mass per volume. What is the unit of mass? We have studied earlier, that is kilogram. Okay. Then what is the unit of volume? That is cubic meter. Okay, or meter cube. So the unit of density is kilogram per meter cube. Here the mass is a fundamental quantity. In volume, how can we find volume? Volume is equal to length into breadth into height. These length into breadth into height are a type of fundamental quantity. Hence, density is a derived quantity. Okay, is it clear? Okay. There are certain rules to be followed while writing units. So, this is our last topic. What's the name of our topic? The rules. There are certain rules to be followed while writing units. The first one is the symbols of units are written using small letters A of the English alphabet. The first one is the symbols of units are written by using small letters of English alphabets. Okay, for example, meter. How can we write meter? That is by using small m. Okay, then second. How can we write second? How can we represent second? By small s. Okay, so the symbol of units are written using small letters of English alphabets. For example, meter, that is represented by small m. Then second that can be represented by using small s. Okay, the next one. Do not mix the name of unit with the symbol. Okay, do not mix the name of unit with the symbol. Okay, okay, I think all of you got cleared. Okay, so our chapter is over. I think all of you got cleared. From today's class, we learned about fundamental quantities and examples for fundamental quantities also. Then we learned about derived units also, example for derived units. Okay, then there are certain rules to be followed while writing units. Okay, so these are about our first chapter. Thank you.